is also room for more sponsors, so if you or anyone in your company wants to be involved, we want to keep doing these. We want to keep being able to bring everybody together. So if you're interested, reach out to me or Rachel, or email founders@sublayer.com. And then also a special thank you for the sponsors who've been with us through these last 5 events, or anybody that's been to all of them. You've all made it possible, so thank you. And then one other announcement. Jake asked me at RubyConf this year. He said he heard that there was a Ruby AI meetup in New York, but didn't know how to find it, which inspired us to actually rebrand to Artificial Ruby and put together a site, which we have a few updates going out now, where we have information about the events, signing up for the mailing list, information about our sponsors, and going to continue to be adding more. So if you or your company can sponsor, we do welcome contributions. So any information about Ruby and AI is welcome. Reach out to me. Happy to include anything. There are ways to get involved. But with that out of the way, we can get started with the speakers. The first speaker we have is Landon Gray, a RAG Demystified, a Ruby Gem deep dive, breaking down retrieval augmented generation into digestible Ruby components. So, Landon, I will let you take it away. Cool. Oh, I need to stand. Okay, cool. Hello. That sounds good. How do I share my whole screen? I think this is how you do it. Sorry. It's like fancy clicker thing. I don't know if it's actually. Sure. Can you hear me all right?
Yeah.
Can you see my screen? Probably
Yeah.
not. You can?
Yeah.
Oh, okay, but you can't see the slides. Perfect. You see the slides now?
Yeah.
Awesome. Try the clicker. I'm not gonna full screen because it's gonna. I built a lot of transitions in here, and I forgot that they were there, and I don't know how to turn them off. So it'd be like 100 slides instead of just like 30. So sorry about that. I'd like to make it bigger though. No?
Command plus.
Command plus, yeah. Okay, cool. RAG Demystified. I'm going to talk really fast. The last time I gave this talk, it was 30 minutes, so I cut a lot of slides down. It's going to be 6 minutes, sorry. And then I have a demo, because last night I couldn't sleep, and I was like, I hate the demo that I had, so I just rebuilt a UI and all this fun stuff. So, RAG Demystified in 6 minutes, 87. So, my name is Landon Gray. I'm going to skip that. So we have a lot to cover. So what is RAG? What is the problem that it solves? And how does it work? We're going to cover indexing. And then we're going to cover something called retrieval and generation. Then I'm going to do a really quick demo. What is RAG? RAG is a shorthand for retrieval augmented generation. It's a way to augment the LLM with knowledge from your data corpus. So documents, files, folders on your computer, you want to pass that data to the LLM so that you can retrieve it and get better responses. So typically, we as LLM developers or anyone using ChatGPT, someone will write a user prompt, and this is the normal flow of a user prompt, then they're going to pass that prompt to the LLM, and they're going to get a response. The problem with that is you get hallucinations. It makes stuff up all the time. Like, it's not grounded in your data, and since we don't have relevant data, we want to use that relevant data that we have, so RAG is the solution for that. So if you've ever tried to play with LLMs, you start trying to pass up data yourselves, and one issue that you will find is you will quickly run into an issue where you have a limited context window. So what that means is the LLMs can only absorb so much text that you're passing to it before it cuts it off, and then you don't have the additional context for your data. So the responses aren't so good. And so I like to show this slide because it kind of gives you sort of like rules of thumb. Like, okay, tokens and context windows, like how much data can these things actually absorb? This is like my little quick cheat sheet. So a token is about 4 English characters. 100 tokens is about 75 words. 6 tokens would be something like Ruby is a fine programming language. And GPT-4 and I believe Claude 3.5 currently take about 128,000 tokens. So you can fit about 96,000 words. Now, I really suck at numbers and all that stuff, so like it doesn't really always connect in my brain, so I like pictures. So if GPT-4o and Claude 3.5 can fit about 96,000 words, it can basically fit the whole 1984 George Orwell's books into its context window. That's a lot of data, but you know, if you're a company like Gusto, you probably have thousands and thousands of documents. You're not going to be able to fit all that into the context window. And so you need to split it up some way. So this slide is the whole sort of retrieval augmented generation flow, and I'm going to run through this and kind of show you how it all works. So first, we have this indexing step. And we need to split the documents into several different parts so we can feed them piece by piece, only the relevant documents to the model that we need to answer the question that we're trying to answer for our model. So there's, in the indexing step, there's chunking, embedding, and then you store the data embeddings. So for chunking, we basically need to take all those documents and split them into arrays of text. Then we take those arrays of text and we're going to generate something called an embedding. So embeddings are a way to convert words and sentences and other data into numbers to capture their meaning. So embeddings are essentially, you can think of them as vectors, or I like to say for developers, just an array of floats with a special property that within this array of floats is encoded the actual meaning of the sentences and the words within the sentence and the relationships between those words among other embeddings that you create in your other documents into these numbers. So those numbers just look like gibberish, but they have meaning. So we take our chunks that we split up, we pass them into a special model called an embedding model that generates the embeddings and encodes that meaning. Now, this embedding model is not OpenAI's, GPT-4 model. It's a special model trained specifically to encode that meaning. And then the last step is pretty easy. We throw it into a vector store or a vector database. We need to store data somewhere. So that's indexing in a nutshell. Next step is retrieval and generation, which is going to be the bottom section. So now, how do we get back those relevant chunks after we pass a question or query to the LLM? So in this case, we have what shows are similar to Star Wars. That's our question that we're asking ChatGPT or Claude 3.5. We embed that with the embedding model so we can get our little array of floats that has the meaning of that question. And then we can do this special thing where now that we have everything as arrays of floats, we can compare them using a computation called cosine similarity, which you may be familiar with from, I can't think of geometry or whatever. So we can compare how close all the other bits of text that are also embeddings are to the question that we answered. And we can get however many back that we want that are similar to that question. So you can say, give me the first item that is most close to that question, or give me the first 10 items. So this is beautiful now because we've kind of split it up. We can get the first 10 items back, so we're getting the most relevant chunks from the documents that we have, and then we can pull those chunks out. So what shows are similar to Star Wars? This is a fictitious, contrived example that I made up, but we can do a comparison in our vector database, and we get star, starfish, and Star Trek. And they all have the word star. It's probably not actually like that when you embed things, but this is just an example. So then we take that query, that question, what shows are similar to Star Wars, we take those results that we got of similar documents, star, starfish, and Star Treks, we combine them into a prompt that we're going to send to the model, and then the prompt's going to kind of look like this. This is an actual prompt from a library that I wrote called SimpleRag. But we're going to pass all those chunks of text, the question, directly to ChatGPT, and we're going to give it additional context that we prompt engineer. And then we're going to pass that prompt to the LLM, and we're going to get a response. And so that's sort of a recap of the search and generation step, and that's it. So I also have a demo, and this will be pretty quick. I don't know how I'm going to do a demo in whole day, but we'll figure it out. Okay. Can everyone see this? Is it big enough? A little bigger? Oh, man. Bigger? Smaller? Bigger. Go big. I'm from Texas, so everything's big. Well, I'm not from Texas. I'm from upstate New York, but I live in Texas. So everything's big. So I like big things. So I was supposed to change the name to Busto, but I forgot. Because I was like, I don't want to actually put Gusto. Gusto did not make this. So it's terrible if it fails. It's on me. It's not on them. But I have this fictional company that I had called Busto or something, which is an HR payroll assistant. But it's really like not smart. It doesn't really know what it needs to know to answer questions for customers. So if I tell it like hello, wait for it. It's like I don't even have any documents yet. I don't even know why I'm here. What are you all even doing here? You program Ruby. Go learn some Python. Okay, so it doesn't have any documents. Doesn't have any context. Can't help the user. So let's teach it. So I'm going to go to the Gusto website, and I want to make it like an assistant that can help answer questions about sick leave because one of you sneezed on me, and I have to go back to work on Monday, but I work remote. But I still am going to take a sick day. So I'm going to give it some information from the Gusto website about sick days. So there's all this information. I don't want to scroll through this, so I'm just going to Control All, Control Copy. We're going to go over here. We're going to add our own document. We're going to paste it in there. And we're going to say, I'm sick tomorrow. Awesome. We're going to add that. And then, lo and behold, a document is added. So let's ask the question again. Let's say hello and see what happens. Get the zoom bar out of the way. Pesky. Zoom is watching. Please make your bars better. So we say hello. And hopefully we get a better response. And this is why live demos are fun. Okay, cool. So, it actually gave me a really weird, bad response. No, it didn't. Okay, scroll. It seems you're looking for information about sick leave policies. Yeah, totally. That's not what I was looking for. But let's ask a specific one about, like, New York. So, what are the policies in New York? Can I get a time check? Am I at time? Okay, I got one more quick one and then we're done. We're checking out the policies in New York. I just want the policy. I don't want to scroll through that. It's thinking. I made this in less than 24 hours, so. Oh, it came up. So, okay, so these are the New York State sick leave requirements. And it says, like, employees earn 1 hour sick leave for 30 hours work. So you go here, and you say New York. And we should see right here. You get 1 hour every 30 hours work. So cool, it seems to be working. I want to ask it one other set of questions. This wasn't the one I wanted. Let's pick something random then. Well, I was just going to go through another flow where I copy some more information and ask a question before and after, but that's basically the demo. But that's kind of what you get with retrieval augmented generation. And there's ways to tweak these systems to make the outputs a little bit better and better and better and better, and then you evaluate it. Eventually, it's so good that you launch to customers and they love it, or you get a lot of hate mail. So one or the other. So that's all I got. Thank you. Check. Okay.
Thank you, Landon. Next up, we have David Corson-Knowles, AI code reviews and Rubocop, shaping Ruby's future, from PR reviews to linting, how AI tools are evolving Ruby development. And we here. I should have taken a little bit longer on that intro.
You're using this new Zoom feature that's like geo-local sharing. You don't actually join the meeting, you just hit share screen. And it's gonna work like magic in 3, 2, meeting passcode. 7-0. I'm in. I'm in. I'm in. Guys, we can do the talk. Okay. I am really nervous because there's a luminary speaker right in front of me. Many of you probably know Eileen. When I was at Chime many years ago, I read her blogs at GitHub about upgrading Ruby and Rails. And I was like, guys, we need to do this here. We were like a Series B startup and we didn't have an upgrade policy yet. And I was like, we are going to collapse under our own weight at the rate that we're hiring and scaling if we don't have a upgrade policy. And I was able to force that through like because of Eileen's blogs. So she's basically my engineering hero and she's sitting right in front of me while I give you this talk. Okay. My talk is about AI code reviews and Rubocop and shaping Ruby's future. And I'm just going to give you, well, I'm going to talk about this first. We live in an era of post-Turing test computer science. This is crazy, okay? Like, I don't know, I see a lot of age range in this room. But, you know, most of the history of computer science, nothing had passed the Turing test. In the last 2 years, we have passed the Turing test, like with flying colors, right? And it's really weird because the thing that passed the Turing test, LLMs, large language models, don't understand anything. Like they literally are not intelligent at all. And no matter how many times we tell ourselves as humans that this thing with language, this thing that is better at talking than more than half of the people on the internet, because it's read almost all of, you know, the stuff that's on the internet, has no actual underlying intelligence. It's just auto-completing the next most likely syllable, word or sentence. It doesn't sink in, but I keep telling myself I'm hoping that my mind will eventually adapt to it. A little about me. I work on architecture and performance here at Gusto. We have a performance guild. I co-lead it with 2 other people, and one of them is going to be featured in my talk because he's going to give a demo by video. And I'm hosted in our People OS department. My team is here. They have graciously agreed not to heckle me for the duration of the talk. And I serve on the board of directors for Ruby Central, which I'll get into in a little bit more in a second. And I love Rubocop, so I'm going to talk to you about Rubocop today. Oh, wait, where's my, my slides are out of order. Sorry, team. I'm going to get my talk out of order. Yeah, so Ruby Central. So I really wanted to have nice slides for this, so I borrowed the ones that a design friend of mine lent to Ruby Central as our internal side template. And so I decided that we would be kind of informally, this talk is informally sponsored by RailsConf, which is coming here to Philadelphia this summer. And you all wonderful people should really come to Philly. You can hear much better speakers than me, like maybe Eileen. And it's the Tuesday to Thursday right after 4th of July. So bring the AI energy to RailsConf this year. It's our final one. So in 2026, we'll be combining RailsConf and RubyConf. So this is the final RailsConf. So it's a big send-off celebration. Okay. Back to the first part of my demo. This is a tale of 2 pull requests. So at Gusto, we have now in production live for engineers a AI pull request reviewer that ranks each pull request on how likely it is to cause an incident. And my favorite part of this is not in this screenshot, but it's the part at the end, which says like, does the pull request description match the diff? And one of my teammates was like, hey, when the pull request description does match the diff, it gives a long explanation of why it does that. Can you make it just say that they match? And so I amended the feature and it does that now. But here's an example of what it looks like. I'm not going to go too into detail because we might patent this or something. So I can't give you all the internal details, but I could say that if you are coding at scale, like at this day and age, you should be using AI in the pull request review process. It's really fun, really helpful. And here's an example. So we have 100% code ownership at Gusto. If you want to use the tools that we use to enforce code ownership, it's part of our open source contribution. It's in the repo Ruby at Scale on GitHub. So go check that out. Just Google Gusto code ownership. It'll be fine. And we had a PR that changed one of the settings for code ownership. And the pull request reviewer flagged it immediately. It's like, this is high risk. So we removed that and it's low risk. We're using a plugin called Danger to power this. We have like 30 different danger rules, which pales in comparison to Rubocop. We have 1,000 Rubocop rules enabled, and we have 75 of them that are written in-house, which is where I'm going to get to with this talk. If you're coding with LLMs, like if you're using Cursor, or VS Code or the plugin to RubyMine, etc., I highly recommend turning on Rubocop as well. Many of you, I see, is kind of an august audience, so I think many of you are already doing this. But yeah, the thesis of my talk really was going to be that the Ruby community is in a really nice place because we have 20 years of history of people writing really good, intelligible code. And so LLMs are trained on that good Ruby code. And we have nice frameworks, linting frameworks like Rubocop that help us enforce that and that are customizable. So I have a whole blog post coming out on Gusto Engineering blog. You can see that kind of thesis in more detail. But I realized, like, for a demo talk, I should really just kind of pitch you on Rubocop. And I wanted to give you an example. So we found in production in our like kind of multi-million line code base some examples of code that like worked but didn't make a lot of sense. So if you've used min by or max by or min or max in production, you know that both of these can take a block, but they take different kinds of blocks. So let's get into let me prep you before I get to the code. So min by and max by are kind of like the user friendly version, where you can just pass a proc or a block, and it will take that block and evaluate it and sort your array accordingly. Whereas min and max are meant to be like super fast and easy to use. It just gives you the min or the max of an array or any enumerable object. But if you pass it a block, it has to be a comparator block, which means it has to work. You have to pass it a block of the form, takes an argument A, an argument B, and it compares them and returns either 0, 1, or -1 in order to sort your list. So we had in production some code that was passing a proc to min or max, and then somehow returning a valid result, which you may have never seen happen. And so we had a long discussion in Slack about what this was doing and why it worked. And we realized that, here's the example, the bad example. So, we're washed out. I'm sorry. I really thought green on black would work well for this. What if we highlight it? Can't highlight it because I'm in demonstration mode. I can describe it. Thank you. Okay, so this is a Rubocop rule. It's a custom Rubocop rule. It's one of the 75 that we have running on Gusto's codebase. And it's documented at the top with this like example block. And the bad example is like, let's say you have an array that has 3 arrays in it, and those arrays are array 3 times, array 2 times, and array 1 time. And you pass it array.min and then the proc count. Okay, so the array of 3 times, the count of that would be 3. So you would think that would be the max, right? And it returns 333, which is the largest object, the longest object. Like, oh no, how did this happen? It's because the count is returning a number, and the min method is expecting a comparator block, and so it just compares the number. So it kind of just works, and it just gives you a random answer, basically, is what's happening. So you kind of want this to not happen in production. If you have a couple of examples in your code base, and you have AI helping you read your code base and then generate new code for you, you can see that you could rapidly propagate problems like this that are not returning reliable results. It turned out that the examples that we had in production weren't actually causing errors. They were just sitting around being bad examples of how to code and potentially going to become errors for other people. So we wrote this custom Rubocop rule. I want to talk to you about Rubocop a little bit. It's kind of works on a plugin model. So basically, like if you want to write your own custom Rubocop, you just define a class that inherits from Rubocop cop and then any module. You can just make this up. This is actually called a department because they've leaned really heavily into the, cop analogy. And you can optionally have an autocorrector, which we do for this one. And you just have the message that you want to pass. If you can use multiple hooks. There's multiple hooks supported by Rubocop. So basically, you just define one of these hooks. It's called when Rubocop runs. And so the onSend hook is called like literally every time a method is called. And so when you use onSend, you should use a restrict onSend definition, which means like only call it on these methods. In this case, min and max. And so when min and max are called in the code base, it does a couple of comparisons, checks that there's arguments, checks that it's getting a block passed to it. It checks the method name, and then it adds this offense and says, hey, basically, don't pass a block like this to min max because you will get errors in production. So I've been working to open source many of Gusto's Rubocop rules. We've done like 5 in the last year. So we still have, as I mentioned, we still have like 75 to go. I'm working on it. And then this is the really fun part of like working with Rubocop is like when you write the specs, you're just writing Ruby code. And you want to see like what does the rule detect the problem with the Ruby code and will it fix it? And in this case, it does. So you might all be asking, are LLMs ready to fix our Rubocop violations for us? And this is my guest demo. This is my friend Peter Harris, who co-runs the Performance Guild with me. So last week at Gusto, we had an all-hands AI hackathon. So everyone at Gusto was working on AI tools. It was a non-production hackathon, so most of it was, prototyping stuff that we could be shipping for customers. But I tried to create a safe space for people who are shipping to engineers, and we shipped a bunch of things to engineers to improve AI-based tooling. This, we'll get into this. Is Peter seeing if AI can fix Rubocop violations for us? This, I will reflect on it afterwards. Let's take a look.
Hello, I'm Peter Harris, and I used my hackathon time to try and build a Rubocop to-do doer. For those who aren't familiar, we use Rubocop to enforce a set of standards on our code base consisting of best practices, patterns, or bad things to avoid. Often when we introduce a new rule, we essentially draw a line in the sand and log exceptions for existing violations while preventing new ones. These exceptions end up in the file called Rubocop to-do, which contains nearly 130 different rules, and between those, nearly 26,000 exclusions. This is a huge backlog of work that people rarely think about, but it means unacceptable patterns live on in our code base. Some of these rules are relatively benign and can even be auto-corrected, while others are flagging dangerous code that are incidents waiting to happen, but require more substantial effort to fix. I wanted to empower an AI agent to fix these exceptions and clean up our code base. I started with a performance collection literal in loop rule, which flags instances where we create arrays unnecessarily in loops leading to increased memory usage and worse performance. These are pretty easy to fix, and the AI generally did alright fixing them, but it was all the other steps involved where I ran into trouble. The general workflow was, given a rule, look at the to-do list and pick a file, remove that file from the exclusion list, run Rubocop on this file to point to the exact issue, fix the issue, test with Rubocop again, and find and test RSpec relevant tests. I started with Cursor's agent mode and quickly hit a limitation where it was unable to modify the Rubocop to-do file. When I asked why, it initially suggested that the dot in the file name meant it was a system file, and Cursor was restricted from editing those. It turns out that's not true, and after much more trial and error, I figured out it's the length of the file, which is 14,000 lines, that was the issue. It eventually tried using external commands to modify the file, but frequently removed the wrong lines, which broke the workflow. Eventually, I figured out a set of commands that worked and wrote a new Cursor rule documenting the workflow, and enabled YOLO mode to allow it to execute a set of acceptable commands. With this, it could successfully process a file or two, but Cursor would frequently error out or just hang indefinitely and require restarting the IDE. I later transitioned to using the Goose command line interface, and things initially seemed smoother, but quickly devolved again. My issues included Claude either erroring out or just hanging indefinitely and never responding. It would frequently skip steps of the workflow despite explicit instructions not to. It seemingly didn't know about backend restrictions and ran afoul of them and then got stuck in loops. And in one case, it fixed a few lines and then randomly removed hundreds of others. It replaced nearly all the tests in a spec file with just the comment, "the rest of the tests." At one point, I attempted to tell it to fix the next 20 files and went for a walk, and the session died after processing just 2.5 iterations. Even when it worked, it would take nearly 2 minutes per file and still require substantial supervision. Ultimately, I got one PR up with about 10 files fixed, but even with a honed process, it still took more human effort to oversee the process than it would to manually execute these changes. I'll be interested to revisit this idea as the tools mature, as I'd love to kick off a process like this overnight and review it the next morning to burn down this list.
Pretty damning. I'm actually quite hopeful. I think that this the video was like a blooper reel, right? But it demonstrated a lot of potential, and the pace that we're going, I believe that Rubocop will soon be able to help fix violations in our code base. But it aligns pretty well with
I'm Peter Harris, and I used my hackathon.
It aligns pretty well with my general thesis, which is that we should be policing what AI is doing in our code bases. There we go. Okay, so I can now wrap up my talk. As I mentioned, we just did a whole week hackathon on AI. We're hiring heavily for AI. If you come work on our AI program, you can work directly with our technical founder. So you're basically like the CTO's peer. So yeah, come hang out with us. And if you liked some parts of this talk, many of them will be captured in upcoming blogs on our engineering blog. Thank you so much.
Thank you, David. We're halfway through the talks. If anybody wants to grab a drink or snack or anything, maybe we'll take like 2 minutes, stretch our legs, and then finish off the rest of the talks. We should definitely talk. So like our framework is designed for like scripting a lot of these things.
I didn't include this, but Sublayer basically is a public competitor with my internal tool.
Yeah, if you're looking for kind of semantic linting, reach out. No, I was going to say, while everybody's milling around, so we've got a framework designed for scripting a lot of these things, like a lot of the things that you're putting together by hand of take Goose and Cursor and all these things, script it with Ruby, so it makes it really, the Ruby way, make it really quick to put these things together. So yeah. Just definitely chat afterwards. Really cool stuff.
Thanks.
Hi there.
Steve? Hey, how's it going? I think you're up next, right?
I'm up next. That was my question.
Okay, great. Yeah, we can kind of get set up and everything. Did you already get a chance to talk to Maple about?
I have not talked to Maple.
No, okay. So there is, did she send you Zoom? Okay, cool. You're all set up. We can take this intermission to get you all set up. Cool. Yeah. Were you at any of the previous events?
Well, I saw you talk.
All right, we're going to get started here in a second. First, yeah, thanks. First time trying like the intermission. Evolved, but
Okay. I will try to project.
Hey, everybody, we're going to get started here in a sec. Right. Hey, everybody. Boom. Boom. Come back and sit down. What's that? All right, one more time, everybody. We're about to get started. The next talk's about to start, so head on in. Come on, you back in the kitchen. Let's go. There will be time to hang out and chat afterwards.
All right. Hi, everyone. Woo.
Yeah. Sorry about that. A little flustered. First time trying an intermission. Thanks for making it back to your seats, everybody. Next up, we have Steve Brudz. Sorry. With Rise of the Phoenix, AI-powered test generation, how Rails developers ship faster and with more confidence with AI. And so with that, Steve, take it away.
All right. Thank you, Scott. Hi, everyone. I'm Steve Brudz. I'm a principal engineer at Def Method, and I'm going to talk to you about Phoenix and specifically for this very technical audience, lessons learned while building this AI-powered test generation engine. So I'll start with a story. I'll give a demo of Phoenix, and then I'll talk about the key learnings. So meet Maple. Maple was newly hired as the CTO at Cat's Paw LLC, and that is a startup that helps keep cats happy by delivering toys to them every week. And they've been growing fast. They've been doing great in the market, but lately they've been hitting some pain points. These are buggy releases. It takes forever to get things done. People are just they don't want to work on certain parts of the code base because they're such a mess. And so Maple goes in and she takes a look at the code base, bird's eye view. She runs Ruby Critic on it and looks at the churn versus the complexity. And so the churn is down the bottom. It's the number of times that file has been had changes committed to it. And then the complexity is like the flog score. And look at that file up in the top right corner. That's huge. It's complex. It's big, and it looks like a catastrophe. But usually those files, that's where all the business logic is. There's a lot of like important, valuable stuff in those files that change a lot. So Maple also takes a look at test coverage. And as you can see here, there are some files that have test coverage, but they're mostly on the smaller side. And there's some really big ones that have low test coverage and some like 1,500 line files that have no test coverage. And so what Maple can see just with this quick assessment is that, it's classic technical debt. It's hard to work in a code base like that. But Maple knows what to do, how to fix things. You go in when you need to make changes to an area. You write your tests both for the stuff that you want to change, but also for all the other stuff that everybody else wrote. You write those tests, you make your changes, you get them passing, you refactor, you rinse, repeat. But that takes a long time. It's hard to estimate. It's hard to get the business to pay for that, even if they're complaining about quality problems. And humans and cats don't really like doing that work. It's kind of mind-numbing. So Maple, being a smart cat, she thinks there's got to be a faster way. So Maple's been trolling around Reddit and she hears about Phoenix and she checks it out. Oh, AI-powered test generation, full unit test suite for the system. It uses Rails testing best practices. You know what? I'm going to give this a try. So now I'm going to pause. I'm going to switch to a demo. So I'm not actually going to show the Cat's Paw LLC code base because that doesn't exist. It's a fake company. And so instead, we're going to look at Human Essentials, and that is an open source Rails application. It is in active use. It's used by diaper banks around the country to manage, their inventory. And it's a good real world example to generate tests for. And so we start off, we do a fork of the repository, and once we have that, then we have a test harness here that we can kick off. Let's see, I don't want to improve things right now. So let's say I want to generate tests for all the models that start with product. And I'm going to kick off this workflow. And so this takes about 10 minutes to run. So I'm going to do the food network version of this demo, and I'm going to show you the pre-baked cake in a moment. But first, I'm going to talk about, actually, let me go here. I'm going to talk about what's happening behind the covers. So up here, this is our forked repo. We have our target classes that we put in there. And so what that GitHub Actions workflow you were seeing that we kicked off does is it initializes Phoenix. It does an analysis using LLMs to kind of look at things like, is it using FactoryBot? Is it using, RSpec? Is it Minitest? So it generates a sort of like a file, and I'll show you that in a moment, that's like can be used as information for the test generation process. We set up a test database so we can actually run the tests, and we index the code base. So we're not actually using standard vector-based RAG. We tried that. With code, we didn't have great results. So we tried writing our own kind of parsing library that we called Rails Grokr, and that worked to a degree, but we started hitting kind of actual Ruby rules of like resolving module namespaces and things. So we ended up switching to an LSP. We're using SolarGraph, and so that's basically a tool just like what your editor uses to help you navigate the code base. We're using it to help the LLMs be able to navigate the code as well. And so once all that setup is done, then we start off the test generation process. And I'll talk about this in the lessons learned section, but we're doing a lot in parallel, and we're breaking down these big classes into smaller bits and saying, all right, let's just generate the test for a particular method. And we found that we get much better results when we do that. And we start off, we have the LLM look at, this method, figure out what the test structure should be, what are all the paths through that should have test cases. And then we have another pass that actually implements the test cases. We run them. We have a fixing loop that runs a couple times. And in the end, we bring all those test cases back together again, run the tests, report code coverage. We send that to a Snowflake warehouse so we can keep an eye on, how are things going, and we generate a pull request. So let's see. Before I show you the pull request, this is the output of the analysis process. So it's identified that we're using RSpec. There's different gems that are being used. A key area is what FactoryBot factories are available for use in generating the tests. And we found that, especially for legacy, like code bases with like a lot of nested, tangled dependencies, writing tests using FactoryBot is, you get sort of a higher quality result. Let's see. So let's take a look at the tests that were generated. So this is an example that I had generated before in the interest of time. So, it's doing this particular method. It's using contexts. It's using FactoryBot. And we're still like tuning it to try to get better and better results. And get the level of tests that an expert human could write. But it's been a fun process. All right, so I'm going to stop here and head back to. All right, so we'll talk about some meat right now. So some key learnings. So for LLMs, they are like kind of like a bunch of lovable misfits, and in that they're capable of great things, but you have to keep an eye on them, or they're just going to run amok. As other speakers mentioned. And so trying out different providers, different models. We've had luck with OpenAI's GPT-4o, with Claude's Sonnet 3.5, 3.7, as well as StarCoder. But we've run tests comparing them and their results, and so different models have different strengths. And for instance, like the newest model, let's say OpenAI's O1 model, we actually have not found that to be great for test generation. For some reason, it hallucinates more garbage, and we get better results with GPT-4o. There'll probably be a new model that comes out at some point that's better, but we're going to keep evaluating. And as I said, we report the data to Snowflake, so we can actually look across runs and see what kind of progress we're making. And one important thing I think is really worth highlighting is that if you keep the info you're sending the LLM small and focused, you're going to get better results. And that's not just true in test generation. It's also true, like if you're working in Cursor or something like that. Like if you say, fix the tests in this file, you're not going to get as good results as if you say, fix this test and then fix that test. It's so keeping it specific, we found, is you get better results. And finally, another thing to note is that LLMs use probabilities, so you're rolling the dice. You're not going to get the same results every time, which is a pain, but it also can be an advantage because you can roll the dice a few times and take the best pick. And the last point is, because LLMs aren't always consistent, what we do to make the kind of level of quality higher is we use traditional automation. Like we write code. If we can do it with code instead of doing it with an LLM, we're going to go that way because we know we're going to get consistent results. And we use the LLMs, where their strengths are. Another key learning is that monitoring is really important. There's a bunch of options out there. It's a really sort of, I guess, burgeoning field of different vendors that will capture all of the interactions that you have with the LLM. We're using Langsmith right now, and I tried a few others. They're all pretty similar. But as you can see on this image on the side here, this is a trace from a run that my coworker Keith and I were looking at last week. And we were noticing that some of the runs that we had were using like 10 to 13,000 tokens, and this one used 89,000. And we're like, oh, why did that happen? What's going on? And so when we dug into the trace, we found that this second task here actually, instead of outputting nice Ruby code as it was supposed to, it output a summary. And that got the future task all confused, and it just went off. We also have a tool that, well, actually, I'll talk about this in a moment. We'll come back to that. The last thing I think is really worth noting is that put in timeouts and recursion limits when you're automating AI-related stuff, because AIs will run amok. And early on, I started a process and I didn't look at it for like an hour and a half because I was in a meeting. $200 later, I had to apologize to Joe. He was nice. He didn't take it out of my paycheck, though he threatened to. But yeah, we put in timeouts to keep them from going amok. So another area that we found important, because we're trying to process a large amount of data in parallel, is concurrency. So we're using Python. It's not my favorite language. We didn't know about sublayer when we started this project, or I would have tried it. But Python has a couple different concurrency models. It has coroutines, and it also has threads. And I think it's important to look at what your application is actually doing. So in our case, like, we're making a lot of API calls, so we're IO bound, we're not CPU bound. And so in that case, we should use async IO, and that is sort of a single process that interleaves things. But it works, as we've learned, it works differently in Python than in JavaScript. So area of learning, but it's definitely something to pay attention to as you're programming. Concurrency is just hard in general, and you can easily shoot yourself in the foot. And if you're spinning up lots of things at once and using one of these LLM providers, you have to watch out for rate limits. And the more you use them, the more money you give them, they'll bump your limits up, but it's still something that we hit sometimes. Another area, speaking of sublayer, is that we've switched to using an agent-based workflow. We started with LangChain, which was sort of it's like a previous generation framework. It's weird to say that since it's 2 years old. But we started using LangChain. We hit some limitations because its processing is almost like more linear, if you will. And we needed something that had more flexibility. So we switched to Crew AI, and Crew AI has agents. Agents can use tools to accomplish tasks, and it lets LLMs collaborate. So we have an LLM that is responsible for writing code, and then we have another LLM that's a code researcher, and the code writer can ask questions of the code researcher, and the code researcher kind of has the big context window, and it can give sort of more accurate answers, smaller answers back to the code writer. So it's powerful, it's slower, it costs more, but we're willing to make that trade-off, especially if we can spin up a lot in parallel. Finally, I think Postel's law is a really important point. Other folks, when you're talking about Rubocop, this is a key area. The LLMs, you need to validate what they produce, and if they screw it up, send it back and say, do it again. And Crew AI has some really good features around task outputs, where you can say, all right, it must conform to this particular schema. They also have guardrails where you can actually run like a Ruby process or Rubocop to say, check this code, and if there's violations, then go fix them before continuing on. And this is another Futurama reference, because we sometimes feel like just screaming when the LLMs go rogue on us. A little bit about tools. Tools are the things that we're using to say, we're letting the LLM, query the file system, or find a particular FactoryBot factory to use. And we found that the more specific you can make the tools, the more accurate and reliable the results will be. But it's good to have general tools as a backup. So there are times when no factory exists for a model. So we give the LLM tools a general way to kind of look through the code base and say, all right, well, what do I actually need to create an instance of this domain object if the factory doesn't exist? And we've seen agents use them in surprising ways. There was one that lets them look at a particular location in a code base and we expected it just to kind of take that and use it in a certain way, and then we found out it was actually using it to look through certain parts of different files to find information that it needed. And it's all right, well, that's cool. I don't know if I'm seeing a monkey learn how to use a stick and make tools out of it, or it just this is kind kind of built in, but it was neat to see. Let's see. All right, so we'll wrap up here. The Maple, after she has Phoenix generate this whole test suite for her, it provided a safety net for her team to be able to go in and start making improvements, reducing that technical debt. And 6 months down the line, there's still a lot more work to be done, but the team's focusing on making things better instead of putting out fires, and they're able to release more frequently, faster speed to market, less failure rate, and happier developers, happy cat. So thank you for your attention, and I don't know if we have time for questions, but
awesome. Thank you so much, Steve. That was amazing. And now for our next talk, we've got Eli Block. We'll let you get set up here. Thanks a lot for Steve. That was really cool to see. Yeah. There we go. Awesome. Hey everybody, this is Eli Block with IntroductionSBot, a Rails-powered social memory, building context-aware conversations with a chatbot that never forgets.
Yes. So I've built another version of what I'm building here. And basically, what I want to do with AI is build apps that where instead of filling out like a set of preset hard-coded form fields, you have apps that you can actually explain what you want from them. And in particular, the application I'm thinking about is an app where a lot of people talk to it, and it does something useful with that, with the fact between people. And I'm trying to build a bunch of different things, in particular, apps that make connections between the different people, a bot that makes connections based on what all the different people say to it. So I have an Instagram account called ConnectionsBot, and if you message it, it'll respond to you with the knowledge of its previous messages. So this is a simple RAG app, really. And I'm going to demonstrate sort of under the hood a little bit with this kind of demo of my app. So pretty much you have the system prompt that you can actually modify, and then you'll see the context below there as I use it. And I'll just say hello to the app. I'll just put in a fake username. And that'll bring up the context because it'll embed that message and then bring up some of these AI generated other people. I don't know exactly what people are going to use this for. It could be like for like social stuff. In this case, I generated a bunch of stuff of like community type posts where people are like looking to connect with people, maybe to get them to join the run club or something. And so when I message, it'll sort of look at this context, and I can also adjust the system prompt. You can play with it so that you can get it to do whatever you want. All it's going to do is insert this other conversations from the top RAG results into the system prompt, and then that'll just be added into the prompt. So I'll just type out a message here. I'm a slow typer. And so in this response, it mentions somebody from the context on the left-hand side there. So it says, it mentions Cortez because it would control that. So there's that at the top. So somebody previously mentioned that I just moved to Williamsburg from LA, looking to meet photography enthusiasts. So that's why when I say something related to that, it draws a connection, and it's sort of so. If you use this on Instagram, that will actually be a link here to their Instagram account. So that kind of creates a connection. But it doesn't necessarily need to be for like making introductions. It could just be for really anything. I'm trying to figure that out. So that's why I'm going to post this demo places and hope that people will try out a different system prompt and I can find a better one. But pretty much that system prompt explains kind of like what this is for. In this case, it kind of says to like make introductions to people. Cool. Yeah.
Very cool. Awesome. Yeah, definitely share it with the group when you get the link out, so you can.
Sure. It's live on connectionsbot.app.
Connectionsbot.app.
And the Instagram account is connected.
Awesome. There you go. Thank you so much, Eli. While I get set up, one more round of applause for all of our speakers. Thank you so much for presenting. I need to get connected back to Zoom. Sorry. One moment, sorry. Yeah, all of the speakers, the information about the talks are all available on artificialruby.ai on the new site with the new events page. So you can click through, connect with any of the speakers. And don't worry, past speakers, we will have you on as well. We're working through that. Also open to PRs if anybody wants to help with the site. So one more thing, we are organizing the next event already. It will be on April 9th at WAP. You can scan the QR code now or the Luma. The link will be on artificialruby.ai. You can also sign up on the mailing list and get an email. I think we will also, if you came to this event, we will send an email to the event that you signed, the email that you signed up for this event at. So keep an eye on your inbox as we get more details. So just one more round of applause for Gusto. Thank you so much for hosting us in this beautiful office. And thank you again to all of our sponsors. You all you're making it possible for us to put on events like this and bring all these people together. So thank you to all of our sponsors again. And thank you to all of you for continuing to come out. It's great to see all of these Rubyists together. It's been so long. It's very great to see all of you. So thank you.